Hello, I'm Emily Shuckburgh from the University of Cambridge. We've all been stuck at home for a couple of months now, and a lot of people have been saying that the air seems so much cleaner. So today we're going to learn all about air pollution. We're going to understand what causes it, how you can measure it. We're going to analyse some actual air quality data to see how it's been changing, and then we're going to investigate what causes those changes. And in that investigation, we're also going to be seeing how we can teach computers to learn to recognise different objects. So I hope that you enjoy this video. Before we start, I'm going to introduce you to my assistant, Genevieve. Genevieve.
We did a last video about ice. This time we're going to do it about air pollution. Here's a fact for you. Lichen can tell us all about air pollution. I hope you enjoyed the video. Bye.
And as Genevieve says, today we're going to be learning about air pollution. And one of the things that can give you an indication of what the air pollution is like is lichen. Now, lichen are these things that grow on trees and sometimes on rocks and stones as well. And there are many different types of lichen. Now, back in last century, in the 1970s and 80s, there was a lot of pollution in the atmosphere called sulfur dioxide. It was a chemical that was in the atmosphere, actually a lot from burning coal, for example. And that sulfur dioxide really damaged lichen, and a lot of the lichen was killed off. Now, there is still today other pollution in the atmosphere, in particular something called nitrogen dioxide. And that nitrogen dioxide can also affect lichen. And in particular, it means that some types of lichen grow better than other types of lichen. Some of the lichen that's a bit more yellow coloured.
Do you find them near roadsides?
Will happily still live if there's quite a lot of nitrogen dioxide in the atmosphere. And other lichen, in particular that lichen that's more green colours, really doesn't like to grow if there's a lot of nitrogen dioxide in the air. And so one way of telling how good the air quality is to look at the lichen that's growing on the trees around where you live. So we're going to learn more about lichen before we start investigating that further. Lichen are actually really special because they're actually not just one organism. In fact, they are at least two different organisms living together. There's a fungus, and then together with the fungus there's either algae or something called a cyanobacteria that lives with it, and lives with it in a way that we call symbiosis. And symbiosis means that one of the organisms, the fungus, helps out the other one, the algae, and vice versa. The algae helps out the fungus as well. So in particular, in this instance, what typically happens is that the algae do use a process called photosynthesis, which is the process that all plants use to turn the sun into their food. So the algae produce sugars from the sun through photosynthesis, and then that is also used as food for the fungus. And the fungus provides a structure for the algae to grow on, and it can also help provide some of the chemicals that protect the algae themselves. So they both benefit each other. Now, Genevieve, can you tell me about any other organisms that live in a relationship between each other that we can call symbiosis?
Urchins and crabs.
Urchins and crabs, can you tell me about that?
The urchins scare away the things that might hurt the crabs, and the crabs find food for the urchin.
Okay. Well, I'll tell you another one, which actually looks a little bit like this lichen here, is coral. And coral, a bit like this lichen, is one animal that creates the structure on which different algae can grow, and they both help each other in that. It's very similar to the lichen, actually. Now, there are different types of lichen, and we have already said there's a difference between the colour of different types of lichen, but there's also a difference in the shapes of different types of lichen. So if I bring the camera over, we can have a little bit of a look at that. Now, here is a plate of lichen that we gathered in the woods just yesterday, and there are various different types that you can see here. So let's have a look at some of them. This here is a very nice, well, it's a bushy sort of lichen, isn't it? And that's one type of lichen. And then there are that one there. Yes, that one's quite different, isn't it? That's almost, it's sort of got this thin crust of lichen over that branch, hasn't it? And then there's other lichen, this might be a good example, where it's completely different. It looks a bit more sort of leafy-like, doesn't it?
Like
so those,
coral.
Well, this one I think is the one that's most like coral, isn't it? This one here, the bushy one. So there are different, they look different, the different types of lichen. These are the ones that we gathered in a wood, and they're mostly of the more greeny colours. And these are the ones that we gathered this morning by the road. And those, there's much more of the yellowy lichen on those, aren't they? And those are the lichen that are happy to live when there's lots of nitrogen dioxide in the air. And the other thing that you can do is you can do an experiment to identify which are the lichen that are that can tolerate the more of the air pollution. But if you want to do this experiment, then there's a few things that you need. You need to put on some sort of clothing that protects your clothing. So Genevieve has got a covering here. Do you want to put that on? And
but
also,
if you don't have a covering, you can just wear an apron or an overring.
You could do, yes. And really, you should put something over your eyes as well to protect your eyes. So let's do your jacket up, Genevieve.
Because this stuff that we're going to put on is a bit poisonous.
And you need to ask an adult to help you with this, because what we're going to be using is some bleach. And this bleach has a special lid on it here so that children can't undo it because it's dangerous. So I'm going
to... It's a bit poisonous.
It is. I'm going to pour a little bit of it. We also have a special pipette to pull it out with, but you could just use, this is a syringe we have from some medicine, that you might have one of those at home that you could use instead. And what we are going to do is we're going to put a small amount of the bleach, thin bleach, onto the yellow lichen and see what happens. Sit there. We're going to put a small drop of this onto some of the yellow lichen, and what I want you to do, Genevieve, is tell me if you see it change colour at all.
It could turn a bit pinkish or a bit reddish.
Well, that's what we're looking out for, to see if it turns pink or red.
Sometimes it just goes there for a bit of time, sometimes it stays there for a long time.
Okay, let's
so you never
see.
Actually know.
Let's see how we do. Where shall I put this? I'm going to put it a little bit on this one here and see whether or not we're seeing any change in colour. Not really, are we?
It looks a bit orangey.
Actually, it might be going a bit orangey.
Put it a bit more on.
A bit more on? I think actually, if you look carefully, those ones have gone really quite orangey, haven't they? So we're going to go off and have a look at a real measurement station that measures air pollution that's just around the corner here. But before we do, we thought we'd stop off at this tree here, because you can see on this tree lots of lichen growing, and you can see there's two different types of lichen.
There's silvery bluey kind and a yellow kind.
That's right, two different types. And this is the type that grows even when there's lots of nitrogen dioxide in the air. So when we go to the measurement station, we're going to come back and we're going to look at the actual data that's being measured, and we can look to see how much nitrogen dioxide there is in the air around here. So should we go off to the measurement station?
See you there.
Let's go. So it's a bit noisy here because we're next to a road, but this is an air quality measuring station, and there's two different things that it measures. The first thing that it measures is the amount of nitrogen dioxide, and if you can see at the back of this, it's got a white tube, and it's in through that white tube that the air is taken to measure the amount of nitrogen dioxide. And nitrogen dioxide is not good for your health, especially if you have asthma or some other condition that makes it more difficult for you to breathe. And the other thing that this measures is the amount of what's called PM10. And PM10 are little small particles that are in the air of soot or other chemicals. And those particles are really tiny. They're almost 10 times smaller than the diameter of a single piece of hair. So they're really small and they can get into your lungs. And they can have an impact on your lungs or on your heart. And if you're either elderly or very young, a child, then that can be bad for your health as well. So it's not good to have either nitrogen dioxide or lots of PM10 in the air. Now, the nitrogen dioxide can come from cars. You can see a lot of those going back and forth across here, or they can come from burning of fossil fuels or from other industrial processes. And the PM10 also comes from cars. It can come from burning the petrol or diesel in the cars, or it can come from the tyres as they go along the road. It can also come from construction if there's lots of dust being produced by construction, or it can come from industry as well. So those are the different things that get measured in this measurement station here. And what we're going to do is we're going to go back, have a look at the internet where we can see the actual data that is coming from these machines inside here that are measuring the air quality at this location. We have found the website with the data from the air quality station that we were just looking at in the street, and this is it. And what you can see on this webpage, if we go down here, this is the latest data, and it says that this monitoring site data was just updated. And we can see here there's two of the things that we were looking at being measured. So first of all, there's this thing called PM10, and you can see here that currently the pollution of PM10 is low. And then the other thing that we were looking at is nitrogen dioxide. That is also low at the moment. Now, what we can do is we can look to see how the amount of PM10 and nitrogen dioxide have been changing over the last few weeks. And if we want to look at that, then we can go up here to create graph, and we can see how they've been changing. Because the one thing that's changed a lot over the last few weeks are the number of cars that have been driving down the roads, because everyone has been staying at home because of the coronavirus. And so what we want to see is whether or not the fact that everyone has been staying at home and not driving has meant that there's been any changes in the amount of air pollution. Now, here we can see that what we can do is we can look at the data over the last few months. And if we want to do that, we need to put in the date that we want the data to start. So if we say we want it to start back in February, that was before everyone was asked to stay at home. So we'll put the 1st of February until today. And we're now in the beginning of June. And then we're going to look, well, let's look first of all at the amount of nitrogen dioxide. And this is the data for how the amount of nitrogen dioxide has been changing since the beginning of February.
So let's see from when it was from the highest point.
So that's all in February.
Those two
high
are
points.
very, very high.
And then
now it's gone really low. So it's basically around 30, 40 and around there.
there are other things that can affect the amount of nitrogen dioxide. In particular, the weather. So if there's really not much wind about, on a particular day, then that might mean that there was very different amounts of nitrogen dioxide at that location compared to a day when there was lots of wind around that was able to blow in fresh air, for example. So we have to be a little bit careful, because actually sometimes in the winter compared to the summer, there are different amounts of nitrogen dioxide anyway in the air. So just looking at this data, although it seems as though there were higher levels in February than there are now, we can't be absolutely certain that there's a big difference compared to this time last year. So we'll come back and have a look at that in a minute. Before we do, let's just have a quick look at the PM10 and see how that is looking for these same periods. So we're going to, instead of clicking on nitrogen dioxide, we'll click on PM10 and we'll create graph again and see what that looks like.
There we go.
And what can we see here? Can you see any changes over time?
Well, there was a very high bit up there, and it's actually quite low.
So what would you say?
It's around 10, 20.
Mostly around 10, 20, and then the highest values, which were again in February. These are the dates at the bottom here. So this says the 29th of February 2020. And so sometime, it must have been around about the 20th of February, 21st maybe, there was a very high level of PM10, and you can look at all the data of all the years and try and analyse them. What actually one of my colleagues from the University of Cambridge, Alex Archibald, he's done exactly that. So this is the data that Alex has been looking at, and he's taken exactly the same data as we've just been looking at and looked to see how this year is different from years in the past. So what you can see in grey, that's what the typical values are in the last few years. So 2017, 2018 and 2019. The last few years, that's what the levels have been. And this is from January through to June. Now, then you can see in blue here, this is what the actual measured values for this year, for 2020, have been at the place where we've just been looking at the air quality station. Now, would you say that compared to this grey area, that the current, this year's levels of nitrogen dioxide have been bigger or smaller than it was in previous years?
I think it looks a lot smaller.
It looks a bit smaller, doesn't it? The blue is below the grey area for most of the time. So let's then look at the PM10 and see whether we can see a difference there. So this is now the PM10, that's here at that same location we've just been looking at, the air quality station. What would you say about the PM10? Has there been much difference in this year, 2020, in blue compared to the last few years, which are shown in grey? Or would you say that they're pretty much the same?
Some bits look like it's a bit higher, some bits look like it's a bit lower.
That's right. So it's not all the time a bit lower, is it? So
No.
we might wonder why it is that the nitrogen dioxide seems to be lower, whereas
than
there
the
doesn't
PM10.
seem to be much difference in the PM10. PM10, some of the things that can cause lots of little dusty particles in the air that might be PM10, lots of building works and construction that can create it. So maybe that's one of the reasons why there's still quite a lot of PM10. Next, we're going to have a look at how the number of buses, cars and people walking down the street has changed over the past few months. This data from my colleague Ian Lewis shows how the number of pedestrians has changed. And what we can see here is that this was the normal number of people walking down the street, and then this is when everyone was asked to stay at home on the 23rd of March, and you can see there have been many fewer people walking on the street compared to normal. Only about, can you read what this number says here?
30% out of 100%?
Only about 30% of normal number of people walking down the streets. Now we can then look to see what's been happening to other things. So this is the number of cars on the roads. And again, what would you say, how many cars are there compared to normal?
Quite a big drop, because it was 100%, then it
Normally.
Yeah, and then it dropped to
30%, I think.
Yeah, and it's gone on one tiny bit there. It's gone a bit in the middle of 10.
You're right, it is. It's about 15% here, isn't it? Why do you think that there are these some days of the week there's slightly more cars and some days of the week there's slightly fewer cars?
Maybe because some people are allowed to go to work a few days a week, and maybe those big drops are the weekend, so people don't go to work at the weekend.
I think you're absolutely right. And then what you can see is that here there's just a little tiny bit of an increase, isn't there, as more people are starting to go back to work probably. Right, let's have a look. This is the number of vans. There's an even bigger difference in the number of vans between the weekdays and the weekends, isn't there?
Mm-hmm.
And there's slightly less of a drop in the number of vans. There'll still be more vans driving around the road than there are cars, perhaps because of people doing
Food deliveries.
Food deliveries, that's a good idea. Again, it's increasing again now. And that's the number of trucks. So there's definitely been a drop in the number of vehicles, of cars and vans and trucks on the road since the end of March, when everyone's been told to stay at home. So we would expect the amount of pollution being less. Now, the final thing we're going to look at is how this data was gathered. So how do we manage to measure the number of cars and trucks and people walking along the roads? Should we find that out?
Mm-hmm.
Cameras like this one up here watch the roads, and then a computer identifies the cars or buses or people that are walking up and down the street and then counts them. So this is our own way of teaching a computer to recognise, well, we can either get it to recognise a picture of a cat or a picture of a dog, or we can try and get it to recognise what we want to try and do, the difference between whether there's people walking down the street or cars or buses. So should we learn how we can teach a computer to do this?
Mm-hmm.
So this is it. What we have to do is we have to do 2 stages. So first of all, we need to get some data, some pictures to train the computer model, and then we are going to set that up working so that it can learn and then test it. So that's what we're going to do. Should we give it a go? And you remember that when we were out in the street, you took some photographs of people in the street and cars and vans and things going down the street. So we're going to use some of those to help train our computer model. So let's give it a go. Now, what we have to do, as it says here, is drag pictures either from your computer, or you can also draw things and put them into this box here, things so the computer knows what a picture of a car is. Now we have put in 10 examples of cars, 10 examples of buses, and 10 examples of people. So let's go back to the project and learn and then test. What you have done, you've collected examples of images for a computer to use to recognise when images are cars, buses or people. You've collected 10 of each of them. What next? Ready to start the computer's training?
Yeah.
Click the button below to start training a machine learning model using the examples you have collected so far. So let's do it. All completed. So what it says here is try putting in an image to see how it is recognised based on your training. Right, let's see whether it will test on here.
Okay, test. Does it recognise recogniser says?
Recognised as cars with 91% confidence.
Ooh!
Now, if you'd like to do any of this yourself, you could look on the internet to find the place closest to you where they're measuring air quality. And you might even be able to go and visit the measuring station like we did, and you could look on the internet at the data and analyse it in exactly the same way we did. And you could also see whether you could set up your own way of teaching a computer to recognise different objects. You might need an adult to help you set that up. And don't forget to go for a hunt for all the amazing types of lichen that might be growing around where you live. And if you find anything exceptionally interesting, then tell us about it. So I hope you've enjoyed learning all about air pollution. But before we go, let's just have a little bit of a think about how we all might be able to try and help improve the quality of the air that we're all breathing. So Genevieve, what sort of things do you think we could do to try and improve the air quality?
Maybe we could drive less cars.
We could drive less cars, that's a good idea. And do you think there's other things that would be good about driving less cars?
It will stop climate change happening as quickly, and it will also... What would you do instead of driving cars? How would you travel about it instead? You could walk if it's not too far. And you can also cycle.
You could cycle. And do you think walking and cycling is healthier? It's better for your health than going by cars? It is, isn't it? So that's one way that everyone could try and help improve the air that we all breathe, is by walking and cycling more rather than going in the car where you can. I hope you've enjoyed this video, and we look forward to seeing you again soon. Bye.
Bye.